This is Divyasri from second BTech and first semester, and this is my CA2 assignment. My subject name is Electrical Circuit Analysis. My topic is waveforms of symmetry in Fourier transformers. Waveform symmetry. There are three types of waveform symmetry. First one is even symmetry, odd symmetry, and half wave symmetry. Even symmetry. A function is said to be have been even symmetry. The condition is f of t equals to f of minus t. Like this is the xy plane, f of t, and t is a small t and t. This is a triangle or square or rhombus, anything. The triangle is dividing the both planes in equal parts. So this is an even symmetry. In even symmetry, an equals to 4 by t integral 0 to t by 2 f of t cos n omega t dt. A naught equals to 2 by t integral t by 2 sorry a naught equals to 2 by t integral 0 to t by 2 f of t dt. Bn equals to 0. Odd symmetry. A function is said to have an odd symmetry. F of t equals to f of minus t. Odd functions are symmetrically about the origin. This is the odd symmetry. This is the origin. In odd symmetry, the axis is passing through the origin is known as odd symmetry. In odd symmetry, Bn equals to 4 by t integral 0 to t by 2 f of t sine omega t. Half wave symmetry. A function is said to be half wave. The symmetric condition is f of t equals to f of t plus or minus t. The values of f of t are equivalent opposite. Therefore, if n is odd, a naught equals to 0, an equals to 0. If n equals to even, 4 by t integral 0 to t by 2 f of t cos n omega t dt. If it is odd, if it is even, 4 by t integral 0 to t by 2 f of t sin omega t dt. This is an odd symmetry because the line is passing through the origin. That's why it is known as odd symmetry. Here we have to consider the limits as 0 to 2 pi because this is a one cycle. So 0 to this point and this point to pi and pi to 2 pi. So first we have to find out the slope of a line. The slope of a line formula is y2 minus y1 by x2 minus x1. The y1 equals to y2 equals to a. This point is known as the a. So y2 equals to a and y1 equals to this slope, right? So y2 equals to a and y1 equals to 0, x2 equals to pi and x1 equals to 0. By this we can solve y equals to a by pi into t. It is an odd symmetry. The formula of the odd symmetry is Bn equals to 4 by t integral 0 to t by 2 f of t sine omega t dt. Bn equals to 4 by t. The limits are 0 to pi. A by pi t sine omega t dt. Bn equals to, we can take a and pi taken outside, 4a by t pi into limits integral 0 to pi t sine omega t dt. So in this here we applied a integral uv formula. The integral uv formula is integral u dv u dt sorry. So the integral uv formula is integral u dt minus integral u dash minus integral v dt. So we substitute this formula here, 4a by t pi into t into minus cos n omega t by n omega into minus 1 into minus sine n omega t by n square omega. So 4a by t pi into pi minus cos n pi. So here we apply the limit 0 to n pi. Here the limits are 0 and pi. So here we apply the limits. Instead of t, we have to write the pi. So if we substitute pi here, minus cos n pi by n and minus 1 into sin n pi, sin pi equals to 0. So 0 by anything? 0. So 0 into 0 also 0. That's why I wrote 4a by t pi into pi minus cos n pi by n. So by this we can write 2a by t pi into minus cos n pi by n. Therefore Bn equals to 2a by pi into minus 1 whole square. Thank you.